Oh, good morning, afternoon class. Today we're going to review some factoring of trinomials, and you might recall this is just sort of a reverse of the FOIL method. This is something that's done in Math 371. We generally spent about 6 weeks at the end on factoring. So let's see how good we can do one day of review, 6 weeks of stuff, but we'll see. Let's start off just reviewing how to FOIL. We were foiling, let's FOIL this out. 5x minus 7 times 2x minus 3. You remember first, outer, inner, last. We were doing that. I'm going to say last week, but I really mean week before last, okay? So we start FOILing this out. 5x times 2x, that would be 10x squared first.
What's the outer product?
Now let's do the outer. First, outer.
What are we going to get there?
5x times a negative 3x. Times a negative 3. Negative 15x.
I
Good.
agree.
That's outer.
Inner.
Now inner.
Minus 14x. Okay.
And then
last.
Is that going to be what? Negative times negative.
Positive 21.
Oops. I was labeling F-O. What letter was I going to put here? I and L.
First, outer,
now,
inner,
which
last.
of these have some terms that we can combine? Which terms can we combine here?
15x, negative 15x, and then negative 14.
Okay. Outer and inner, we're going to combine. So the 10x squared, there's nothing to combine with. The outer and inner, negative 15x plus a negative 14x, that's a negative 29x. And then plus 21. So what y'all are telling me is that the outer and inner terms combine together to give the middle term. I think this might be the first time that I'm about to say something that I'll say over and over during the next few months. In algebra, you always go one way, and then you go in reverse. What we just did here was FOIL this out. What we're about to do today is going in reverse. Given this, it's called a trinomial because there's 3 terms. 1, 2, 3. Terms are separated with equal signs and pluses and minuses. So that's why this is called a trinomial. Try for 3. 1, 2, 3. If we're factoring a trinomial, what we're going to try to do is just sort of we know how to FOIL. So we're going to be going in reverse, trying to figure out what numbers go in here in order to get that. Let's do another one. How about?
So what we're going to be doing in this class is reversing the FOIL method. We'll be going from the expanded form and trying to go back to the factored form, the form that's a product, the parentheses.
So let's FOIL this out.
First,
7x times 2x. What am I going to write there? I'll get us started. 14.
X squared, I agree, outer. Minus 35x. Inner. Plus 18x, I agree.
First.
Last times last, what are we going to have? Positive 9 times negative 5. Negative 45.
So is this like the other one? Can I combine the outer and the inner? Yeah. So combining the outer and inner terms. We have a 14x squared. What is that? Negative 35x plus 18x? What's that going to be? Positive or negative?
Negative.
Negative. And then we're subtracting
17x, I agree.
minus 45. So there's no gentle way to do it. We just sort of got to jump into it. It takes a lot of thought up here, going from this backwards. The first thing I want to point out, if we were going, okay, start here and go backwards. Start here, go backwards. Let's look at this last number. What sort of numbers multiply together to give a positive 21? Well, they're either got to both be positive or both be what? Negative. The only way you're going to get these last two positions to multiply together to give a positive is if you have the same sign here and here. I'm going to call this the first sign, that pointing at that this minus in front of the 29, and I'm going to call this one right here the second sign. Like right here, I'm pointing at what I'll call the first sign, and I'm pointing right now at what I'll call the second sign. In general, if the second sign is plus, that means you need either plus plus or minus minus. How do you decide? You look here. What sort of numbers multiply together to give negative? Here it says negative 45. Would a positive times a positive give you a negative? What about negative times negative? No. What do you have to have if you're going to have two numbers multiply together to give you a negative? A positive and a negative. I'm going to make.
You should write those statements.
I'm going to make a table which is going to show. Okay, so I'm going to make a little. Try to summarize what I'm saying here. I'm going to write a table about how to factor a trinomial. I'll write it like this: ax squared plus or minus bx plus or minus c. So a, b, and c are numbers. Okay?
And this works when a is positive. When you're going to want the leading coefficient to be positive. And if it isn't positive, then we'll have a way of handling that. But assume that the a value for this little rule that Tony's writing, it assumes that the a value is positive.
And that's what I was about to say, but you got it in there before me. This first number we'll assume is positive, like the 14 and the 10, and that's a good assumption. That's why I'll call this the first sign and the second sign. You might want to call, some people call this, what I'm right here, the last sign.
First sign and the last sign.
Okay, my brother was talking about the first sign and the last sign. Okay, but I'm going to make a table. It's going to have 4 columns. Oops. I have to write kind of small. The second sign. Oh, I said second sign. I said I was going to say second sign. You know what?
That's what you said, second sign.
I know, but you would like to say last.
That's okay.
Second sign. If that second sign is positive, like this one over here, positive 21, then the factored form has to have 2 of whatever the first sign is. Factored form. So I have a column, second sign, factored form. If the second sign is plus, the factored form has 2 of the first sign. What I'm telling you is how to figure out the signs in the parentheses. Hopefully it's clear to you what we're going to be doing. Given this, you come up with this. So I'm first telling you how to decide on the sign. If the second sign is, Ooh, that says immediately. If the second sign is plus, you have 2 of the first sign, I'll fill those in immediately because I know what they are. If I were factoring this, second sign is plus, 2 of the first sign, so put minus and minus. That's the first thing I would write in the parentheses. Now, what about if the second sign is minus? If the second sign is negative or minus, what sort of numbers multiply together to give a negative? Well, 1 positive and 1 negative.
So if that last sign is a minus, you're going to have 1 of each sign in the parentheses. You'll have a plus in one of the parentheses. You'll have a minus in the other parentheses. And you'll wait to fill in the signs.
Now, this last column, this is sort of unfortunate what I'm about to say, and I'm sort of choking when I say it, but not really. Once you know how to factor, this table will make a lot of sense, okay? But right now, right off, you might not get what I'm about to say here, but I'm going to write it out. Oh, no. I think one of us forgot to turn off our ring. I know I did. To get the middle term from the outer and the inner, like right here, the outer and inner, we combine to get that middle term. What did we do to the 14 and 15 to get a 29? Did we add them or subtract them? You add them. Adding 15 and 14 get you the 29. What about here, the 35 and 18? We're not adding 35 and 18 because we have a negative and a positive. So what are we doing to get the 17? If we're not adding, subtracting. And, oh gosh, it'll make more sense once you've done it. Or if you already know how to do this factoring, then you're thinking, oh, that's a great table there. Okay, I can show it to another teacher and they'd be like, oh, that's a good table. Unfortunately, if you don't know how to do it, I'm not sure how much good this table does. But certainly right here, okay? Oops, I can't see where I'm pointing.
Oh, wait, I thought you were going to do an example.
I am, yeah. You see, right there, that's how I'll start all of these. And we're doing problem number 1. It's a good thing that I'm starting this low on the page. 3v squared, that is a v, right?
Right.
Plus 10v plus 8.
And
oh, the instructions say factor. If the instructions say factor, your answer is going to be 2 sets of parentheses. Okay? So, I'm going to move this up.
This process, this reverse FOIL process for factoring trinomials is frequently, well, now it's called reverse FOIL, but back in the olden days, it was called trial and error. You make up a FOIL problem and you FOIL it out and see, do you get back 3v squared plus 10v plus 8? If so, great, you're finished. If not, you mark out what you have and you create another FOIL problem. So you are going to be just trying these various combinations until you get one that FOILs back to give you 3v squared plus 10v plus 8.
Now to get
we know something about the signs inside those parentheses. I'll be quiet.
No, my little table here. Let's look at the second sign. What's the second sign here? That plus. If the second sign is plus, the factored form has 2 of the first sign, fill it in immediately. That means I need to put plus here and there. Second sign was plus, so 2 of the first sign. Since I know they're both plus, I can just go ahead and fill them in. It's when you have 1 plus and 1 minus, you don't know where it goes. Does the plus go in the first one or the second one? That's why I say wait to fill them in. Now, it is a trial and error, but it's an intelligent trial and error. By that I mean we know that the first two positions have to multiply together to give a 3v squared. Well, to get a b, that'll be easy. Just v squared, it'll be a v and v. But what numbers multiply together to give 3? 1 and 3, that's it. So I'm making a note. 1 times 3 will give me 3. Now, the last two positions need to multiply together to give 8. What numbers multiply together to give 8?
1 and 8.
1 and 8 and
2 and 4.
2 and 4.
Realize 1 and the number itself will always be a possible pair. Okay?
Now,
Even if the number's prime, you'll still have, like 3 is prime. You still have 1 times 3 to give you 3.
now we're foiling out. There's no other possibility for 3, 1 and 3. I'm going to fill that in immediately. 1v, which I'll just write as v, and 3v. If I started foiling, is v times 3v going to give me 3v squared?
Yes.
Yes. Now, we've got to, here's come that thought, we've got to figure out which pair of these should go here and here. How do we decide? Well, which pair will make this work out and we get a 10v when we add those middle terms? Okay, if I try a 2 here, I'm going to try 2 and 4.
Why are you doing that?
Oh yeah, that'll, okay,
Well, do you want to get the correct combination right?
yeah, I'm gonna get it, just because that's how I normally do it. I would start here with the 1 and 3, and I would pair it with the 2 and 4, and see, can I make it work out with the 2 and 4? And what my brother was getting on to me was,
This is going to be the correct combination.
I'm about to get the right answer right off. It might have been better for me to try a 4 and a 2 first, but I'll show that in a moment. How do I know that I've factored this correctly? Well, if we foiled it out in our head, the 3v times v, that's giving me the 3v squared. I have no doubts about that. What about positive 2 times positive 4? Is that giving me the 8? All that's left is the outer and inner. Are those adding together to get that middle term? If I help me out with the outer and inner, we would have a 4v as the outer. And what about the inner? Is that 6v? Do those add together to give me 10v? Then we factored this correctly. And it looks deceptively easy because hopefully you see this is the correct one. Why don't you go ahead and type that in, and then it may have already timed us out. Now, when you're typing these in, the order in which you write the two sets of parentheses doesn't matter. You need one set of parentheses with a v plus 2 in it. You need another set of parentheses with a 3v plus 4 in it. It doesn't matter which set of parentheses you write first.
I could have typed in the 3v plus 4 first, and then the v plus 2.
But when you foiled it out, you would still get 3v squared plus 10v plus 8. Now, hopefully it's clear to you that if I'd done this, this answer right here would be wrong. Why? You see, I put a 2 here and a 4 there. If I put the 4 here and the 2 there, that's what I've done, we'd still get the 3v squared when we started foiling. But are we going to get a 10v? We would have a plus 2v and a plus 12v. Is that going to add together to give me a 10v? No. It'll give me the right last number and the last first, it'll give me the right last number and the right first term, but the outer and inner don't combine together to give you a 10v. Did you type in that answer? Yes, you did. Oh, okay. So this table, it makes sense to someone that knows how to factor, but this stuff right here is sort of important. if that second sign is plus, two of the first sign, fill that in immediately. If the second sign is minus, that's the trickier one, because you've got to figure out, where do I put the plus and where do I put the minus? Like right up here, if we had reversed the plus and the minus, if we had a -5 and a +9 and foiled this out, we wouldn't get that minus 17x there. Okay? So it's sort of a trial and error. Takes a little bit of patience. Let's do number 2. Actually, I'm going to give y'all a little hint. Okay? It'll come in, again, this stuff will follow us all semester long. Okay? We'll be factoring all semester long. And here's a little hint that can help you knock out some possibilities. There should be no common factor, parentheses, other than 1. In the parentheses. Well, again, one of those statements. What the heck does that mean? Okay. Well, let's look at this. Suppose I had this set of parentheses.
4x plus 6.
4x plus 6.
If you have 4x plus 6 in a set of parentheses, your factorization cannot possibly be correct.
What number other than 1 divides into 4 and 6? 2. Can't have it. You can only have common factors of 1. Suppose we did this, 4x minus 9. Would that be okay? What's the only number that divides into both 4 and 9?
1.
1.
Okay, that's okay.
See, that one's okay.
What about 5x minus 5?
Okay, yeah, that's a good one. 5x minus 5. It's almost tricky because it's so easy.
Is that okay?
What number other than 1 divides into both of these?
Should be obvious. 5.
So what am I saying? You can't have 2 of the same number in one set of parentheses. What about 2 even numbers? Could you ever have 2 even numbers in the parentheses?
Mm-mm.
You know what I mean by 2, 4, 6, 8?
They're both divisible by 2, so you can't have.
Cannot have 2 even numbers? And could you have 2 of the same numbers? Like 5 and 5? No. And that will eventually help us figure out, oh, we don't need to try this possibility and stuff, but it might not pop up a lot, but let's see. Let's do number 2. I don't think my little hint here is going to help. On number 2, what's that? 4x squared minus 4x minus 15. When I look at this, I think to myself, oh darn. Why? I think it's easier. I think it's easier if that second sign is plus, because you can fill in the signs immediately. But for this one, the second sign is minus. So that means there's 1 plus and 1 minus, but we don't know where it goes. Did the plus go in the first set or the second set of parentheses? That's why we'll wait to fill them in. But I'm going to draw my 2 sets of parentheses. And we know that there's a plus and a minus. So I'm going to go ahead and write a little note up here so I don't forget. A plus and a minus. And I'm waiting to fill it in. I'm reminded years and years ago, before most of you were born, I had a hostel student and we were doing this. And the student said, "You're just making this stuff work out." And I thought, oh wow, he's a hostel student. I need to diffuse this hostility. And what did I do? I said, oh, brilliant. I'm going to remember that. Did y'all hear what he said? I'm making this stuff work out. That's what we're doing. That's why we made it work out to get that 3v squared plus 10v plus 8. I thought it was a brilliant statement. Not really. He said it in hostility and he was mad, but, you know,
Okay.
I still remember that statement, so it means something. So I'm writing down the numbers that multiply together to give up 4. And over here, what numbers am I going to write out?
1 and 15.
1 and 15. You can either put a comma between the numbers or a dot. It just depends. Like here, I put a comma. I probably should have put a dot. Maybe that'd be better. 1 times 15, and there's another pair.
3 times 5.
3 times 5. So at this point, it's up to you. Do you want to try? What do you want to try with the 4? I always start here first. I can either go 1x times 4x or 2x and 2x. Y'all have my thoughts usually start with the pairs that's closest together. So if I tried 2x times 2x, now realize nothing guarantees that I'm not going to be marking this out and trying it again.
With 1x and
4x. But I'm going to try it like this. I generally start with the numbers that are closest together, and I'll pair them with the numbers that are closest together on the number line. Like the 1 and 15, they're far apart on the number line. The 3 and 5, they're close together. So I'm going to try it like that. A 3 and a 5. Now we want the outer and inner terms to subtract to give us that middle term. So if I started foiling out, and again, I've got to FOIL out just to check and see if I'm doing it right. We'd have a 4x squared. I don't really need to write that because I know that's what we're going to have because I only chose numbers that multiply together to give 4. But okay, 4x squared. Now the outer, I have a 10x and a 6x. And the last term's 3 times 5, 15. Well, we need it to be a minus 15. So we got to have a positive and a negative. Can I subtract 10 and 6 to get that middle term? Yes. So I found the right one. I just got to arrange the plus and minus the correct way. In order to get a negative 15, there should be a plus and a minus. How should I arrange this plus and minus? If I have a negative 4x, I want these to combine together to give me a negative 4x. So which one of these numbers should be negative if the sum is negative?
10.
Okay, make the 10 negative and the 6 positive. Would that do it? If I'm going to make the 10 negative, oh wow. Where does the plus and minus need to be? I want the 6 positive, so would that put the plus here
Yes.
and the minus there?
Yes.
A lot of thought going on here, trying to decide, okay, how do I arrange the plus and the minus signs? Looking at the finished product, you're going to think, well, what did he do? But it's the thought process. Y'all see how I went through it? I decide on the signs. Then I decide numbers that multiply together to give 4, numbers that multiply together to give 15. Then it's just a matter of pairing them. And if 3 and 5 hadn't worked, I would try a 1 and 15. Could I arrange those in such a way that I'd get the negative 4x? If not, I'd try the 1 and 4. This is just a trial and error. The more you do it, the faster you'll get at it. Okay? Fine. Oh gosh.
Are you going to circle your answer before I type?
Oh yeah, type it in. Okay, there.
2x plus 3, 2x minus 5.
2x plus 3, 2x minus 5.
Oh, once again, When I'm typing parentheses, I do not use this hot button here. That's more for an ordered pair, but that comma between it, I just use the parentheses from the keyboard. 2x plus 3, right parentheses, left parentheses, 2x minus 5.
Now, if you had typed in the 2x minus 5 first, and then the 2x plus 3.
Let's do that.
Oh.
The order of the parentheses doesn't matter as long as you have the same thing inside each parentheses. Is that what I wanted?
Mm-hmm.
If you put that 2x plus 3 second, you'll still get the correct answer.
Now, you'll notice look at problems 1 and 2. There's an option B where it says, is prime, go back to number 1, I liked that one better. It says not factorable. Prime means not factorable. Just like prime numbers, nothing else, 5 is a prime number. Nothing else divides evenly into it, just 1 and 5. It's possible to have a trinomial that these little rules just don't work on. They don't factor. Let's look at this example here that I just made up. X squared plus 20x plus 1. The second sign is plus, so what do we know about the signs? The second sign is plus. Are we going to have 2 pluses, 2 minuses, or 1 of each?
2 pluses.
Second sign is plus, so 2 of the first sign. Second sign is plus, 2 of the first, plus and plus.
1x squared, there's only one possibility for that. What times what?
Then we're going to put here and here. I'll get it started. X times x. What are the only numbers that multiply together to give 1? 1 times 1. There's no other possibility. If I FOILed this out, am I going to get a plus 20x for that middle term? No. And
the outer product is 1x. The inner product is 1x. There's no way you're going to get a 20x.
You're going to get a 2x, not a 20x. And there's nothing else you can do. There's no other numbers that multiply together to give a 1.
When he says numbers, he means positive integers.
Let's make the assumption. When I say numbers, I mean just the counting numbers.
And if it's factorable, you can factor it using integer coefficients.
So this one, the answer would be either prime, or it might say not factorable. There will be a problem in here that's prime. I won't tell you. Y'all can help me figure out which one it is as we go through these. Let's do number 4. Just sort of jumping around. Okay, problem number 4. I better flip over, don't you think? Yeah. Number 4. Is that a 12b
squared?
Plus
43b plus 35.
Gosh. 12b squared plus 43b plus 35. Okay. I'm going to draw my 2 sets of parentheses.
Actually, there's something nice about this. We know something nice about the signs.
Second sign is plus, so
2 of the first signs.
So a plus and plus going here. Now, okay, oh wow. Remember years ago a student asking me, how am I getting these numbers? Numbers that multiply together to give 12. 1 times 12, 2 times 6, and...
There's another pair. 3 times 4.
How do you know that? The
Because he got your multiplication
That's
tables
it.
memorized.
You gotta have those multiplication tables memorized. Remember, I was so concerned for that student. Oh my gosh, this was back before everything was so computerized. I got her a sheet of paper with the multiplication tables and recommended maybe she practice, those. But
Whatever happened there?
yeah. Okay. Now, numbers that multiply together give 35. 1 times 35, and there's another one. 5 times 7. I don't think any others will go there. So, oh gosh. My thoughts are,
Okay, I've got it.
I would start with the pair that's closest for 12.
And there's no guarantee that that's going to work.
No.
But if you're not really sure, and you need to start somewhere, so try the closest pair.
I don't just randomly choose numbers and try.
Right.
Okay? Okay, so I'm going to try 3B and 4B. Oh, gosh. And 5 and 7.
I'm going to, here's my thoughts. I don't think we can use 1 times 35, because if we put a 35 here or here, when we start foiling out 35 times 4, aren't we getting a number a lot bigger than 43? 3 times 35, we're getting too big for 43. So I don't think 1 and 35 can work. So the only other option, try 5 and 7. Put the 5 there and the
Put
7.
the 5 here.
Yeah.
And the 7 there.
It's not going to work, but it's good for them to see one that doesn't work. Track that outer and inner. Are you going to get back 43B? What's the outer product?
The outer would give us is that a 21B? Outer. And inner is a 20B. Well, we're going to get pretty close. We have a 21B and 20B. That gives us 41B, but not 43B. So
the 5 cannot go with the 3B.
So if I had...
You better mark out that
Yeah,
other.
I am.
Here's the trial and error part.
Putting the 5 with the 3 didn't work out. So I'm reversing it. I'm going to put the 7 with the 3 and the 5 here. And let's foil it out. Now, I'm going to show you something.
The way you do that.
Here's how my habit on how to show the outer and inner is like this. I make these little marks. And this is simply my way of doing it. You're not going to see everyone else doing it like this. Okay, I'm multiplying 3B times 5. That's the outer.
That's 15.
15B.
What's the inner product?
I'm going to make the same little marks right here. 7 times 4B.
That's a 28B.
I don't know
Realize
if they like
these are
those
positives.
marks, Tim.
Huh?
I don't know
Plus
that they
and
like
plus.
that. Yeah.
Plus and plus.
Are those
28B plus 15B, is that giving you the 43B? What's 28 plus 15? 43B, that's what you needed.
Did
You
y'all,
already know first times first is going to give you 12B.
Yep.
You don't really even have to check that. You wouldn't have written down something that didn't multiply together to give you 12.
like you wouldn't use 3 and 5.
Because
Because,
3 times 5 isn't 12.
okay, so the first numbers you're using are only the numbers that multiply together to give the first number. Like here, you wouldn't use anything other than 1 and 35 or 5 and 7 because those are the only numbers that multiply together to give a 35.
So all you really have to check is the outer and the inner. Do they combine together to give you that middle?
And
And in this case,
do y'all see what I did with these marks? If you don't like it like that, just write it out like I did here. Okay, first is 12B squared. outer would be 15b, inner 28b. Do those combine together to give 43b? Yes. And so,
So 3b plus 7, 4b plus 5. Once again, as long as you have the same thing inside the parentheses,
you could type it
the
in
order
like
doesn't
this.
matter. You can put 4b plus 5 times 3b plus 7.
What you're saying is you can type either one of these in.
My math lab would count either one of those answers correct.
It doesn't matter which one you write first. A 3b plus 7 could be first, or it could be in the second set of parentheses.
3b plus 7, right parenthesis, left parenthesis, what was the other one?
4b plus 5.
4b plus 5.
If it says factor, your answer's got to have those two sets of parentheses. Now I'm mentioning that because in a moment, we're going to have some that with different instructions.
And they're not going to say factor.
Number
Any
5.
questions there?
It's a lot of thought,
And
okay?
there's something wrong with this one. Even before we start factoring it, there's something wrong.
5a squared
Minus 5a.
No, minus
No,
5.
minus 5. You're right.
Here,
Minus
Tim.
24a.
Why don't I turn off my microphone? Oh, well.
Just keep on going. Charlie.
Oh, okay. I was just thinking of that little rule you have, but
Yeah,
it's
you're
almost
right.
nothing else you can use
Yeah,
here.
you're right. Okay.
Okay, you want to go ahead and do
I'll
it?
take over.
Let me just
Well, yeah. Okay. When we're factoring a trinomial, thinking about how when you're foiling out, you get those terms in descending order. So your trinomial needs to be written in descending order before you start trying to factor it. A descending order based on exponents. That's what I mean. Biggest exponent, no exponent, finally no variable. The 5a squared, yes, it's written first.
Wait, Tim.
Oh,
Oh, wait, that was my mistake.
yeah. Okay. That
So
5a squared, that's okay. It'll stay first. But what's my second term going to be here? I have an a squared. Now I need the term that just has a to the first power. Minus 24a, okay. And what's my last term? Minus 5.
Show them the way it's always it was b squared, b constant. A number in algebra that doesn't have a variable is called a constant.
You have to have it in the trinomial in descending order based on exponents. The biggest exponent, x squared, then an x to the first power, finally no x term. That's how we need the terms written. 5a squared. Oh, well, first of all, what do we know about the signs? I'm going to write my parentheses here. So here's my parentheses. We know something about the signs. What are they? The last sign is a
Wait,
minus.
Tim, no, you're looking at the wrong one.
Oh, the last sign is a minus.
And you know what I used to do?
It's sort of dark up here, isn't it?
Should I turn on the overhead light?
Okay.
Is it
too
too
dark
dark
for
in
y'all? No, okay, it's better with the light on here for me. The last sign's a minus, so what do we know about the signs in the parentheses? One plus and one minus, okay? I'm making a note of that over here. I'm going to need one plus and one minus. 5a squared, well, 5 is a prime number. What are the only two positive integers that multiply together to give you 5? 1 times 5? Go and look at that, another 1 times 5. Well, this is nice. There's only one possibility. We can use a 1a and a 5a. So I'm going to write those down. 1a and 5a.
And now, well, for this one here, this 5, we're going to have to use a 1 and a 5. Here's my question. Can I put the 5 right here in the second parentheses? What did I say? You cannot have a common factor inside the parentheses.
Other than 1.
Other than 1. 5x minus 5x, you can't do that. Likewise, 5a minus 5, you cannot do that. So if we're using 1 and 5 for this second 5, and you have to use the 1 and the 5 because that's all you have as a possibility. Put the 5 here and the 1 there. And we know we're going to need 1 plus and 1 minus. Let's check the outer and inner products. What's the outer product? A times 1, that's 1a. What's the inner product? 5 times 5 times 5a, that's a 25a. So we have a 5a and a 1a. Go back, remember when that last sign's a minus. When that last sign is a minus, where is it? When the last sign's a minus, you have to subtract the outer and inner. Can you subtract these outer and inner to get that middle number there, 24? Can you subtract 25 and 1 to get 24?
Yes.
Yes, you can. So play around with it. You know you need 1 plus and 1 minus. To get a negative 24, what sign do you need on the 25a? Does it need to be positive or negative to get a negative 24a when you combine the two?
Negative.
That needs to be negative there and positive there. So where did we get that 25? Where did that come from? The 5 times 5a, it needs to be negative. So put the negative in front of that red 5. Put the positive in front of the 1. Negative 25a plus 25, if you add those together, sure enough, you get negative 24a.
You put a check mark, but the answer is the two
The check
sets of
mark,
parentheses.
you're right. The answer, let me rewrite it. The answer is a minus 5 times 5a plus 1. Is that pink? I guess it's, okay, it's visible. Okay. Ready to put. Any questions there? Here's one thing, well, this one it was obvious because it's only 1 and 5, 1 and 5. One of my little tricks that I use, if this number here is either 1 more or 1 less than the product to the first and last. 5 times 5 is 25. This is just 1 less than that. Use 1 in the number itself. Well, it wouldn't have made much. It did, here, there was no other possibility, but we'll see it more as we move through this stuff. The thought process I use to help me figure out what numbers to put inside there.
Let me
type
type it
in the
in.
answer. Type it in.
So, yeah. So what was that?
A minus 5 times 5a plus 1.
You'll notice I'm not hitting any space keys.
No space
And
keys,
also-
no capital letters in my lab.
Mm-hmm. Instead of doing the next one, let's do 8, and then I want to go back to 6.
Okay, we're going to do number 8 now. Okay, let me write this down. Now, Tony, don't answer this for him, okay?
Okay.
Is this like that previous problem? We're going to have to move the terms around here on number 8? Or is it already in the form we want?
Already in the form.
It's already in the form we want. It's already in descending order. V squared, V to the first, no V. Now my favorite ones are ones where the signs are the same inside the parentheses. Are my signs going to be the same inside these parentheses? Look at that minus sign right here. Are we going to have plus plus or minus minus, or are we going to have one of each?
One of each.
One of each.
Numbers that multiply together to give negative.
So we're going to
1
need
times 16. So
the last sign's a minus. So looking back at my brother's table, it'll be a plus and a minus.
and even without looking at my table, you're multiplying. The last two terms have to multiply to give a negative. The only way you're going to get the last two spots to multiply together to give a negative is if one of them's positive and one of them's negative.
3v squared. Well, 3 is a prime number. It's only one possibility. 1 times 3. So we're going to have 1v and 3v if this thing is factorable.
Yeah, there's one problem that's not factorable.
16. Let's see. 1 times 16. What else could give me 16? 2 times 8. And I heard one more. 4 times 4. When there's multiple pairs, what I do is I start at 1, okay? 1 times the number. Then I start going through quickly. Does 2 go through? Does 3 go through? What about 4? And when you get back to the same number on this side, you're finished. You've got all the possibilities. There are only 3 possibilities.
And I wanted to mention, if this middle number here had been either, what's your little rule, 49
or 47, I'd try 1 and 3 and 1 and 16. If this number differs, the first times last, there's no time for you would really want to do that, but 3 times 16, that's 48. So if this had been a 47 or 49, I'd try the 1 and 3 and the 1 and 16 first.
Otherwise,
it is,
what are you going to try first?
Maybe, I guess we could, what do y'all want to try? You tell me what you want to try.
4 and 4.
4 and 4? Yeah, if you're not sure, try the closest pair more times than not. You'd be surprised that that's the pair you need, 4 and 4.
About 55% of the time.
Yeah.
Over half.
Let's check the outer and inner now. What's the outer product? 1v times 4 gives me what?
4v.
4v, okay. What's the inner product? 4 times 3v,
12v.
12v. And remember, when the last sign is a minus, what are you going to do? Add or subtract these numbers to get that middle number there. You want to subtract. If the last sign is a minus, I'm going back to that table of my brothers. If that last sign is a minus, you got to subtract the outer and the inner to get that middle term. So can we subtract 12 and 4 in a way to get 8? Yes, okay. We found it. Here's the factorization, except we have to figure out the signs. We want a negative 8v. So do we want a negative 12v plus 4, or do we want a positive 12 plus a negative 4? Which one of these should be negative, 12 or 4?
12.
12 should be negative, and the 4 should be positive. To get a negative 12, well, we better put a negative right there in front of that 4. Do y'all follow my logic? The negative 4 times 3 gave me the negative 12. Put the positive there. 1v times positive 4 gives me that positive 4v. And if you add them, negative 12 plus 4, sure enough, you're getting a negative 8v, which is what we needed.
And this check doesn't mean that's the answer. That
The
just means
answer
you
is-
found the right one.
The answer is the 2 pairs of parentheses. V minus 4
That
times
student said,
3. I'm just making it
You're
work.
making it work.
You're right. That is
Brilliant statement.
What happened to that student? Did they never come back, or did they?
No, everyone laughed at him, but
It wasn't.
but it was 1992. That's why I say most of y'all weren't born, but I'm remembering. Oh, I have a fond memory in class when
Involving
teaching this,
factoring.
and a hostile student. I don't have hostile students anymore, and if I do, I don't realize it. Oh my gosh, there's a hostile student out there, and I don't even know it.
I have
Okay.
a question.
Yeah.
I'm listening.
when the negative 12b plus the 4b, why wouldn't it be squared?
No, when you remember combining like terms, the only way you get a square is if it's variable times
Times.
variable. Adding and subtracting, you keep the same variable part, you add or subtract the coefficients. The only time you're picking up the square is in the multiplication stage. V times V, you get a V square. When you're adding and subtracting, you have to have the same variable part, V, yes we do. You add or subtract the coefficients.
$4 minus $12 is just a negative $8. It's not $8 squared. It's only when you're multiplying that you get the square. Okay?
That was a good
did
question.
I put that in there? Did I put in the answer? Let's see. No, I have not. And what was that? A V?
V minus 4
minus 4 plus
times a 3V plus 4.
3V plus 4. Okay.
Number 6.
Mm-hmm.
Number 6. 15x squared minus 2x plus 5. Well, there's something nice about the signs at least. What do we know about the signs? The last sign's a plus. So what are we going to have inside these parentheses? I couldn't hear you.
Either two negatives or two positives.
Either two negatives or two positives. Which one? Let's look at the table. The second sign's a plus. Second sign's a plus. You have 2 of the first sign, and you can fill it in immediately. Second sign's a plus, so we're going to have 2 minuses, and we're not going to have to worry where does the minus go. It goes in both of them, so we fill it in immediately.
Those are easier than the ones where you've got the plus and the minus ones.
I think it's easier.
That's what I think.
15. What times what will give me 15? I can think of 2 pairs of positive integers that can multiply to give me 15.
I'll get them going. 1 times 15.
Or 3 times 5, okay? Now for 5, there's only one possibility. What is it? 1 times 5.
Oh, why don't you fill that in first?
Okay, I'll put the 1 times 5 there.
Normally I fill in the first positions, but since there's nothing but 1 and 5.
Might as well just write it in and see what happens. Now for 15, we know we're going to need an x and an x. But do you want to use 3x and 5x or 1x and 15x?
I would use the 1 and 15 if the middle term, 15 times 5 is 75.
So if this middle term were 74 or 76, I'd start off with 1 times 15. But it's a smaller number. And so I think you better try the numbers that are close together. So, hey, if we're going to use 3x and 5x, can I put the 5x right here? Could I do this? 3x and 5x. Is that okay? Look inside this second set of parentheses. It's what I have written there in acceptable factored form.
What number other than 1
divides evenly into those numbers? It should be obvious. 5, can we have a common factor of 5 inside the parentheses? So that can't be right. Now I want it noted that we buy our own paper. So if you're sitting out there, I think I messed up. Thinking, I'm wasting paper. Well, I'm having to buy my paper too, okay? So we have a -1 and a -5.
Putting the 3 with the 1 didn't work out.
So I better put the 5x here and the 3 there. Do you think that's going to work out? I can already tell it isn't. What's the outer product? What's the outer product here? A -25x What's the inner product?
3, -3.
And since that sign is a plus, we have to add these. Can we add 3 and 25 to get 2?
No.
Mm-mm. No, we can't. So this one doesn't work. Well, we know the only possibility for 5, this last 5, is 1 times 5. So we're going to stick with the 1 and the 5. And we know the signs have to be minuses. What's the only other option we have here? 3 and 5 isn't working. So what's the other possibility? 1 and 15, could I put 15x here with the -5? No, because the 15 and 5 are both divisible by 5. So if you're going to use 15x, you better say 15x and 1x. Is that going to do it?
Y'all see what we mean about, you're going to get a big middle number. 15 times 5, that outer.
That's if you check the outer product, that's a -75. Are we going to be able to get that -2x that we needed? -1 times x is a -1x. If we add the -1 and the -75, is that going to give us the -2x? You sat here playing out. This is all the possibilities. You can't say put the 15 here because 15 and 5 are divisible by 5. We've gone through every possibility and we can't get back that -2x. So what do we conclude? It's prime.
Uh-huh.
You
What
cannot factor it. It can't be
Yeah, it
written
says
as a product. So if you go through all the possibilities and you can't get it factored, then the polynomial is prime. But I'll tell you this much. Very rarely are they prime. If you're going through, okay, one after another is prime, you're messing up. I'll see people on tests. 6 of the factor problems are all labeled prime. No, you're doing something wrong. It is rare to have a prime trinomial, okay? My lab doesn't generate them very often. So if you're going through one prime after another, you're just messing up, okay? This situation is a rare situation where it's prime.
Now, I've mentioned the instructions when we started. I said if the instructions say factor, your answers are 2 sets of parentheses. Like right here, it just said factor, 2 sets of parentheses. Or it might be not factorable or prime, you see? But we're about to get different instructions. Ready to move on? Mm-hmm. Okay, let's just look. How does this problem number 10 differ from number 8? Number 8, it said factor. Number 10 says solve the equation.
Look at how they want the answer. T equals, you're looking for numbers for T. You're no longer just trying to factor. You're trying to find out what number can you plug in for T to make the left side. When you plug it in for both of those T's, you want to make the left side equal the right side.
Years ago in 1992, I was at a restaurant with my brother, and the waiter came up, and he said, do you teach math at Del Mar? Oh, yes, we do, making polite chit-chat. He said, I'm taking math at Del Mar. And, well, how's it going? And he said, it's going okay, but my teacher's an idiot. I immediately began trying to disengage from that conversation. Oh, well, I'm sorry to hear that. I sure hope he isn't really. Oh, yeah, he does. He tells us we got to study the instructions. And I was like, wait.
Yeah, you need to study the instructions. Whether it says solve the equation or factor completely, that's 2 different things. If you just factored if you went through and solved and got V equals a number 8 when it said factor, they'd count it wrong on a test. And if you stop at the factorization on number 10 when it says solve the equation, they'd count that wrong as well. You need to study those instructions and pay attention. Do they want the factored form, which has all the parentheses,
Or do they want you to do more?
to
Okay.
get the solutions for t?
Now, go ahead and discuss go ahead and define a quadratic.
A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers,
No.
but a cannot be 0. I'm going to have an added restriction. I want my a value to be positive. As I said earlier, we want that leading coefficient to be positive for factoring purposes. And if it isn't positive, you'll see what I'll do to change it so that it's positive. We're going to be looking at several methods of solving quadratic equations on Wednesday, but the first method involves factoring. To solve it, to solve an equation by factoring, the first thing you need to do is make sure that the equation's in standard form with the trinomial on one side of the equal sign and 0 on the other side. You have to have 0 on one side. You have to have the trinomial you're going to try to factor on the other side. So I'll say, make sure the equation is in the form ax squared plus b, well, I guess I should say plus or minus, because those can be pluses or minuses. But make sure that you have your trinomial on one side of the equal. The only number you can have on the other side is a 0.
But if it's not a 0, you'll see in a moment.
Then, once you made sure that it's in what we call standard form, the descending order based on the variables and 0 on the other side, we'll factor the trinomial.
That's what we've been doing.
Third step, we're going to use something called the zero factor property. The only way a product can equal 0 is if one or both of the factors are 0. What times 7 is equal to 0? There's only one number that you can multiply 7 by to give you 0. What is it?
0.
0. So once you have it factored form on one side equaling 0 on the other side, set each factor equal to 0. And solve.
And by solve, you mean isolate the variables.
I'll say isolate variable. And we make the assumption y'all have solved linear equations in one variable. So if not, you'll get a quick, I'm sure you have. You could have sat here. You couldn't be sitting here if you haven't solved linear equations before.
That's the second thing they do in development.
Let's go. Let's go back. Here's number 10. The hard part of this is the factoring. Once you get it factored, finishing off the problem is pretty straightforward. This is number 10. We have 4t squared plus 25t plus 36 equals 0.
Okay. Let me show. Again, our answer here is going to be numbers separated with commas. It's not going to be two sets of parentheses. Those instructions matter. I remember the student when I told him, the waiter, that's important. You should be doing that. He then began disengaging. It's another one of those weirdos telling me to study the instructions. And so I don't know whatever happened to him.
Okay, 4t squared. First of all, notice it's already in the form we need.
variable square, variable, no variable, 0 on the other side. So 4, well, there's two pairs that could give us a 4. 1 times 4 or 2 times 2. You tell me what can multiply together to give us 36.
I'm going to do the first one. 1 times 36, and then I'll be quiet.
Does 2 go evenly?
2 and 18.
2 times
2
18,
times 18.
3,
Times 12.
3 times 12, 4,
Times 9.
oh, oops, 3 times 12, 4 times 9, anything else?
6 times 6.
5, 6 times 6, the next number is 7 that we would check, but is it 7 between 6 and 9? If you start like I'm doing, you can list them all out, and when you get back and you're repeating the numbers over here, then you've got all of them. So I'm going to write my 2 sets of parentheses. Oh, goodness. What do y'all want to, well, first of all, we know something nice about the signs. We're getting a break here with the signs. What is it?
Plus and plus.
Okay, the last sign's a plus. You'll have 2 of the first signs. This is actually, okay, this isn't as bad as I thought it was.
And
You get to use the fact that you can't have a common pair, a common factor inside the parentheses other than 1. I believe in most cases people would say start with 2t and 2t, right? That cannot possibly work. If you use 2 and 2, look at these other pairs. Doesn't every pair have an even number? If I put a 2 and a 2, I'm going to have to pair the 2 with a 6 or a 4 or a 12 or 2 or 18 or 36. So 2 and 2 cannot work.
if this number is even, this number must be odd.
We don't have a pair here that has 2 odd numbers. So by my logic, 2 and 2 cannot possibly work. Any questions on my logic? Look here at my scratch work. You put 2t, oops. If you tried to put 2t and 2t,
You can't put a 6 in
you
either
can't put a
place.
6 there because 2 and 6 are divisible by 2. You can't put a 4 and a 9 because the 2 and 4 divisible by 2. You can't use 3 and 12. 3, you put the 12 there. 2 and 12, even number. You can't have that.
Hey, that little statement, I think,
Yeah, I think he wrote
Wrote
out
out.
that you can't have
right
two.
there. 2 even.
You can't have 2 even numbers inside the parentheses because then they're divisible by 2. So with
All
that
of that's
logic,
the way to say it.
2 and 2 cannot possibly work. The only pair that could work for the first one is 1t and 4t. Did y'all follow my logic there?
A lot of thought going on here.
What about 6 and 6? If I put a 6 here with the 4t, is that okay? If I
Could you
put a
6 and 6?
No, because 4 and 6 are divisible by 2. What about 4 and 9? Could I put the 4 here? No. I guess I could put the 4 here and the 9 there. Let's check and see. What's the outer product?
Oh, this is nice.
9t, I agree. That's a positive 9t. What's the inner product?
16.
A positive 16t. Remember, you want these numbers to add together to give you 25. Do they? What's 16 plus 9? Isn't that a positive 25t?
So you have factored it.
I have it factored, but we're not through with the
If the
problem yet.
instructions had just said factor, you type these 2 sets of parentheses in, but it doesn't. That's the new step.
Now, the only way a product can equal 0 is for one or more of the factors to be 0. So we have to set each factor equal to 0 and solve for the variable. So we have to set t plus 4 equal to 0. Set t plus 4 equal to 0. and 4t plus 9 equals 0. Set t plus 4 and 4t plus 9 equal to 0. We need to now solve for t. On the first one, we have that t there. We need to get rid of that plus 4. What undoes addition? What operation undoes a plus 4? It's like those equals are like, the equals are like one of them old-fashioned scales where to maintain the balance, if you add 4 pounds to one side, you got to add 4 pounds to the other. If you take away 4 pounds, you got to take away 4 pounds from the other side. So what I'll do for this first one, I'll show the logic. You're subtracting 4 from both sides. You're taking away 4 pounds from both sides. Then 4 minus 4 goes to 0. So all we have left is t equals 0 minus 4 is negative 4. There's my first solution. If we plugged negative 4 in for t on the left side of the equation and simplified, the left side would equal the right. Now over here, the first thing you undo is addition or subtraction. So really there's only one correct first step to solve this equation. What is it? The subtract the 9.
Mm-hmm.
Now, some of you may have seen, instead of this idea of the inverse operation, some of y'all may have been told, oh, if you want to move a term to the other side of the equal sign, you pick it up, you move it over, and change the sign. So you'll have a 4t on the left. Moving that 9 over, it becomes a negative 9. That's the same thing as just going minus 9, though.
So you're doing the opposite operation, beginning with addition and subtraction.
Now this is, so we know that 4 times t has to equal negative 9. What operation undoes multiplication? We just want a t. We don't want that 4 in front of it. We divide, so we'll divide by 4.
This is called solving a linear equation. You did it at some point in your life because you're in this class, okay? If you've forgotten it, okay. If you've forgotten stuff, that just means you work harder than someone that took 371 last semester and remembers a whole lot of this, okay?
Any questions?
Work harder.
Y'all remember solving linear equations somewhere in your mathematical career? The real work is getting the thing factored. Once you have it factored, just set each little linear factor equal to 0 and solve.
I hate to ask this, but I'm hoping I'll get an answer I want. Is it clear to y'all what the difference, why we're talking about these instructions? Solve the equation, look at the answers, they're just numbers, versus factor completely. The teacher that tells students you got to pay attention to the instruction is not an idiot. You know, so if it says factor completely, and every semester I'll get emails at the time of quiz 1. It counted it wrong, and well, maybe right
Okay,
here
let's
they
go
would
on.
go on this one and go equals 0. No.
Okay, let's go to number
Okay.
12.
12. I'll be quiet. I'm playing your part today.
No, well, this is number 12.
Oh, I like this one.
12b plus b squared plus 35 is equal to 0.
Oh, the answer is going to be 2 sets of parentheses or 2 numbers? 2 numbers.
If the answer is going to be a factored form, it's not going to say variable equals. If they want you to solve it, if we're typing in the answer, it's going to say variable equals.
Well, sometimes it does, and I think you just type in the numbers.
Well, for this one,
For this one it does. Okay, did everyone write that down? Is this in the correct order that it needs to be in for us to solve it?
Yes. No.
No. What should be first?
B
For
squared.
B squared.
Next,
12B.
sign,
So plus.
plus or minus.
Plus.
Plus.
That's a positive. You don't see a sign there, so you assume it's a positive 12B. And last, 35. Okay. This type of trinomial where the leading coefficient is 1 is called a simple trinomial. It's simple because it's simple to get it factored. That's why they call it a simple trinomial, if it's factorable. For B squared, that's a 1. Well, what times what's going to give you 1? The only possibility is 1 times 1. We're going to have a B, 1B times 1B. Hey, I forgot to ask you, what do we know about the signs? We know something real nice about the signs.
Positive.
The last sign's a plus, so you have 2 of the first sign. Plus and plus. Now for 35, well, there's several pairs there. 1 times 35,
By
2,
several,
3,
two.
4, 5 times 7. With a simple trinomial, you can look at the pair and figure out which pair you have to try. You should use. That's another reason this is called a simple trinomial. It's easy to choose the last pair. If that first sign is a plus, if that last sign is a plus, you choose the pair that adds up to give you that number. If that last sign is a minus, you choose the pair that subtracts to give you this number. Only one pair here is going to add up to give me 12. What is it? 5 and 7. Simple trinomials are by far the easiest trinomials to factor. You don't even have to look at outer and inner. You can check that you can select the correct pair based on just looking at the factors of the constant term. And if you FOIL this back out, B squared, outer is a 7B, inner is a 5B. That's a positive 7B, a positive 5B. Adding them together, I get a positive 12B. Is that what I needed? Yes, it is. And then last times last gives you that positive 35. Are we through with the problem? No, you have to set each factor equal to 0. Set B plus 5 equal to 0. Set B plus 7 equal to 0. Solving this first equation, we're going to get B equals. Subtract 5 from both sides, or just pick up the 5 and move it over. Either way, it becomes a negative 5. So there's your first answer. What about the second answer?
-7.
Okay, that means if I took -5 and plugged it in for B and B, the left side would reduce to the right side. If I took -7 and plugged it in for both of those B's, the left side would reduce to the right side. Any questions there?
Type with -5, comma, -7, or -7, comma, -5. It doesn't matter. Right, but I don't type 2 sets of parentheses. Any questions on this? Let's do problem number 15. Just jumping around doing some of these. Follow this up. 20r squared plus r equals 12. You're probably sitting there wondering, what would we do if we got something that couldn't be factored? We'll answer that on Wednesday. We'll see a method that'll solve these equations, even if it won't factor.
But I think this one factors.
Yes.
There's a major problem with this. There's something wrong with this equation. What is it?
It's not equal
It's not
not
equal to
equal.
0. We have that 12. Remember, you have to get the equation written in standard form. The trinomial on the left in descending order. And if you're going to solve an equation by factoring, you have to have 0 on the right. If you're solving a quadratic equation by factoring, it has to have a 0. We have a 12. That means I don't see a sign in front of that 12, so what do we assume it is? A positive. You can either go minus 12, or you can just pick it up, move it over to the other side of the equal sign, and what does that give us? 20r squared plus r, what am I going to have? Minus 12 equals 0.
And at that point, you're finished looking at 20r squared plus r equals 12.
That's gone. Okay, if we're going to solve this by factoring, first of all, we need the factors of 20. Well, there's 1 times 20, 2 times 10, 3, does it go evenly? What about 4? 4 times 5. The next integer after 4 is 5. Well, I've already found the 5 factor, so I've listed all the possibilities. Now let's do the possibilities of 12. What are the factors of 12?
I'll get them going. 1 times 12.
So 2 times 6. Moving on, 3. 3 times 4. 4 we already have listed, so we've listed up. There are 3 pairs for 20. There are 3 pairs of factors for 12. Oh, well, let me write my 2 sets of parentheses.
What about the signs?
Can I just fill them in automatically? No. If the last sign's a minus, that means we have 1 of each, and we wait to fill those signs in because we don't know if we're going to have the plus in the first or the second. Remember Tony's little table.
When we started teaching together like this, I learned all these little rules that Tim does, and Tim learned all these little things that I do.
This table of his is one of these things what the heck is he doing here? Okay. What does he mean, wait and immediately? What are you doing there, Tony? But now I got the hang of his little table.
Just like
last sign's a minus. You have 1 plus and 1 minus. We're going to wait. And remember, outer and inner has to subtract to give you. Oh, hey, I don't see a. What's the coefficient here? I don't see a number in front of that r. What do we assume it is?
1.
1. Okay.
But
I'm waiting for y'all.
Here's one of my brother's little rules. If you multiply 20 times 12, that gives you 240. If this number here were 241
or 239,
then use 1 and 20 and 1 and 12. The first time Tim pulled that rule out, I was like, where the heck did he make up that rule? But it
doesn't
was
anything like your little table.
But
your
the
little
rule,
table.
You know, I've never seen that rule stated in any book.
I've never seen that little table stated in any book, but it works. Okay. Okay, well, what do y'all want to do? I would not try 1 and 20 and 1 and 12. At least I'd go through the other possibilities first. What do y'all think we should try? I tell you one thing, it can't be 2 and 10. 2 and 10 are both even. Look at this one. Isn't there an even number? So that 4 would be paired either with the 2 or 10. Can't do it. What about here? 2 and 6. They're both even. That couldn't work. If we used 1 and 12, the 12 would either be paired with the 2 or the 10. Once again, you have even numbers inside the parentheses. So that can't happen.
So you just said the 2 and 10
cannot work. Did y'all follow my logic there? Those are both even numbers, so you're going to wind up pairing even number with even number.
And theoretically, the 2 and 6 can't work because if you use 2 and 6, you could have put a 4 with it.
You're right. You're right about. Did y'all follow that? If you put a 2 here and a 6 there, you're either going to have a 4 here, or you'll have the 4 there. You'll have the 20 there or the 20 there. The 2 and 6 can't work either. So it's really just a matter of 2 pairs and 2 pairs. Let's try, what do y'all want to try? What do y'all think I'm going to try as first times first? 4 and 5 or 1 and 20?
4 and 5.
I'm going to use 4 and 5 first. Oh, I keep wanting to write R. I mean
It is
V.
R.
4R and 5R. Now, let's start with 3 and 4. Hey, can I put the 4 right here?
No.
No, because we already have a 4 there. So put the 3 there, the 4 there. Let's check the outer and the inner. Let's check the outer product first. 4R times 4. What's that going to give us? 16R. What's this inner product? 3 times 5R. 15R. That last sign is a minus. So these numbers have to subtract to give you 1. The outer and inner have to subtract to give you that 1. Where is this little table? There it is. Okay, the last sign's a minus. The outer and inner have to subtract. Yeah, we can subtract these to get 1. 16 minus 15 gives me 1. So we want a positive 1. Where do we put the plus? Where do we put the minus? Do we want a positive 16 minus 15? Or do we want a negative 16 plus 15? To get a positive 1, which one of those numbers needs to be positive?
16.
The 16 needs to be positive, the 15 negative. So where did we get that 16? It was from here times here, put a negative.
No.
Oh yeah, positive.
Plus.
And then the minus.
You were trying to see if I was paying attention.
4R times, I was trying to see if they were paying attention.
Oh, well, they weren't.
4R times, hey,
Joking.
I take a
4R times 4. And you wonder why they like me better, Tony. You wonder why everyone likes me better. My goodness. 4R. My first day back from radiation, it was the last meeting before, the first day back after I finished radiation. It was the class meeting before final exams.
No, spring break.
Spring break began in 2020. It was March 2020. We had one class meeting and then we went away for spring break. And I hadn't really been in the class, okay? Tony been teaching both of these things. And so, I came in, Tony went through, and then Tony said, and I could tell, oh, everyone likes me, okay? They're laughing at my jokes. Everything's going great. And then it was an 8 o'clock class, and it was about 10 o'clock. And Tony was like, okay, we're finished. It was 8 till 11 classes. And I was like, wait a minute, Tony, we still have almost an hour. Let's do some more examples. And the class laughed and put away their books, and I started doing more examples. And then it dawned on me. They thought I was joking. They didn't like me anymore. When it dawned on them, I was keeping them until 10:50 when the class ended. Tony was like, yeah, we finish early most of the time. Well, I didn't know that, Tony. And of course, the pandemic began, and we never met with the class again. So, yeah.
But anyway, you're not finished.
Oh, we're not through. We're not through. Y'all are waiting. Yeah, I was thinking I was through. What do I have to do?
4R minus 3.
Okay,
0.
set each factor equal to 0. 4R minus 3 equals 0. And 5R plus 4 equals 0. What do we do here first? We're solving 4R minus 3 equals 0. Okay, so we're moving that 3 over. That'll become a 4R equals positive 3. And then divide by 4. Okay. You see that algebra that you think to yourself that you learned years ago and you're like, you don't remember it? Well, you remember this. So there's my first answer, 3/4.
Right over here. What
are we going to do here?
Minus
4. That's going to give me 5R equals 5R equals, oh, you've already said that, haven't you? 5R equals negative 4, and then divide by 5. to give us R equals negative 4/5.
Now, those are the two answers. I just want to see what happens if I typed in the two sets of parentheses, which would be wrong. 4R minus 3 and
5R plus 4.
I don't think it's going to have any idea what you're doing wrong.
It's just going to say
Say
wrong.
wrong. Okay. So obtain a zero, factor, set each factor to 0, okay? If it says solve, that's when you have numbers as answers, and not be fractions.
Switch back. Here's what you're going to be typing in. You have two fractions, and you're going to have to type in 3/4, comma, negative 4/5. That comma is not in the denominator.
Oh,
Do
yeah.
not put a comma in the denominator when you're typing in the answer. If you do, now a few of the equation problems, if you put a comma in the denominator, the programmer let it slide. But once we get to interval notation next week, is it next? Wow, is it
Week
already?
after that.
Week after next? If you put a comma in a denominator, they're counting it wrong. So
Let me make
do
okay.
not put commas in denominators.
So it's 3/4. Don't do what I just did. You
That
see how
comma.
that blue, the comma's in that blue box.
Do not do that. Even though they might accept
They
it
might.
on this one answer, I assure you it's going to get to an important point. And with the cut point method, you go through all this long stuff before you get down
Okay.
here to the answer. And so to go through all that work and then get it wrong because you put the comma in the
Comma.
wrong place, do not put the comma in the denominator. Let me write that down. No comma in denominators.
I think we've done enough for today.
Any questions there?
Now, here's going to be the point where we see if the
Any questions before we start the recording?
or any question you want recorded. If not, let me stop this, and if you have any questions, why'd you do
Stop
that?
it. Stop
I was
it.
getting ready to